Alright guys, back with another hopefully pretty quick video, a bit quicker than 6.2 at least I hope. So here what we have is determine the equations of the following straight lines. Now here a straight line passes through the point 1, 6 and 3, 0. This is taken straight from the worked example. I'm going to do it a tiny bit different to how they do it, so feel free to go and read that if you want to see how they've approached this problem. So, to start with, we have 2 points. Now, obviously, we can't generate an equation out of that of y equals mx plus c. What we can generate, or what we need, sorry, I should say, to form any equation is the m and the c value, and I'll go through that in just a moment. But what we have here is we have 2 points which we can use to find our gradient using this formula. This was given to you during the last video, so if you haven't done so, go and watch how I use that. Now, again, having a look, we should be able to tell immediately which is going to be y2, x2, y1, x1. In this case, the 0.16 occurs first, so our y2 has to be 0, and our y1 has to be 6. x1 is going to be 1, and that's going to be 3. Again, doesn't matter too much though. What that's going to give us is a value of -6. 0 minus 6 is -6 over 2. That's going to be an m value of -3. Now, I'm going to show you one way that you could go about solving this. Okay, what we have is insert the equation. Okay, y equals mx plus c. If we want to finish this, what we do is we have to sub this in, and then all we need is the c value. Now, how they do it in the textbook is they take a coordinate, and they take, for example, 1, 6, and they substitute it. So y would be 6, x would be 1, and they'd solve for that c value. Now, the other way you can do it is by using this formula. Y minus y1 is equal to m x minus x1. This is what we call the point gradient formula. Now, I wouldn't mark you down for whichever one you wanted to use. Okay, they'll both get you the correct answer. Now, in this case, we don't have to use y1 or y2, oh sorry, you can use either set of coordinates is what I'm trying to say here. Let's use 3 and 0. Y minus 0 is equal to m, which was -3. X is just a constant. X1 we've already said was 3. Now what we can do is expand this out. Whoopsie daisy. There we go. Y minus 0 is just going to be y. -3 times x is -3x. -3 times -3 is actually going to be +9. And there's your final answer for that one. Okay. You can go about subbing in here, rearranging for c, and that will also work, but the point gradient formula is all I've used there. And that's how you solve to get the equation for that straight line. Now, next up, what we have here is a scatter plot. Now, the first thing you're going to notice is there's all these little dots here. Okay, you'll see there's 3, 4, 5, 6, 7, 8, 9, 10. That's actually taken from a raw scatter plot. I'll quickly just go to the textbook and show you. That's taken from a worked example up a little bit higher. There. That's the raw data there, and then they've just put mathematics, physics on each axis and instead of x and y, and they've plotted them. So as an example, when someone scored roughly 50, it's about 55, they got 55 in maths, they got 35 in physics. Let's just double check that. It's 55, wasn't it? Oh, it's 50, sorry. 50 and 35. And there we go. 50 and 35. So that point lined up there. Now, what they've done is they've then gone and made what's called a line of best fit. Now, I don't believe this is a regression line. They've stated in the worked example that this was drawn by hand. Next year, one of your biggest assignments will be doing regression lines. So it's important that you understand what I'm about to talk about. Now, so what they've done is they've effectively split it down the middle. You've got 5 points here, 5 points up here. Okay, split down the middle. That's our line of best fit. It follows this trend. Now, what we can do is we can make an equation for that line. Okay, to do that, we're going to pick two coordinates. Now, what I'm going to do is just zoom in a little bit just so I can try and estimate some points a little bit easier. Generally, what I like to do is I like to pick, let's say, this point here. So the first point, I might zoom out again, sorry, I just got to copy this. So when we're picking our first 2 points, here's how I would do it. So we're going to have point 1, and that's going to have obviously an X and a Y. So I'd say that's about 30, and I don't think it crosses over the 20 perfectly. I think it's 30 on the X-axis, 21 on the Y-axis. Now you can use any points. Let's go with the 70. So my point 2, we know it's going to be 70 exactly. We've got that guideline there indicating it. So point 2, we'll use X is equal to 70. And the Y value for this one, I would say, is about 68, 69. It's hard to kind of pinpoint that one. Let's just go 68, and let's see what we end up with. Okay, now again, this is open to interpretation, so I'm just kind of eyeballing it. In fact, I might even, I'll nudge it up to 69. It's probably closer to 69 than it is 68. I could go 68 and a half if I wanted to, but I want to avoid decimals for this point in time. Now, what we can do is we can make an equation for this. So again, using our, actually I've already copied this formula. Using our gradient formula, the first thing we need to do is find the gradient for this line. Now, I've purposely used different points to what the textbook uses, so what I'm going to do after this is I'm going to compare my answer to theirs. They should be the same, but maybe a slight bit different. So 69 minus 21, and then we've got 30 and 70 here. That's going to be 48. So 48, that should be 70, sorry. And 40. Simplifying it down, I prefer to keep it as an improper fraction. Halving it would get it to 24 over 20. That should be 24. So 24 over 20. Halving that again, we'll get 12 over 10. Halving that again, we get 6 over 5 as our gradient. I'm just going to check what the textbook got as their gradient in their calculations. Again, I'm not... Yeah, oh look, we line up perfectly. So even though we've used different coordinates, they use 40, 33, 80, 81, we used 30, 21, 70, 69, we ended up with the same gradient, 1.2 or 6 over 5. Okay, 6 over 5 is 1 and 1 over 5, that's 1.2. So awesome, good to see there. If we did have... in an exam setting, if you did write that down as 68, you know, we allow for a plus or minus 1 in this case, maybe 2 if we're feeling generous. But we certainly wouldn't mark you down, okay, in that case. Now that I have that value, I'm just going to quickly shrink this. Of course, it's gone hiding. Just condense some of the space we've got here so I don't flow onto another page. We use our formula, point gradient formula, to find that equation. In this case, I'll use 0.1. Again, doesn't matter. Just keep in mind, if you do get a negative coordinate, remember to put the negative in there. So if it was negative 30, you'd have to make this negative 30. Obviously, it isn't, so we don't need to. But just be aware that, you know, there is a minus there. The gradient we've already worked out was 1.2 or 6.5. Our x1 value... Oh, I just realized I've used the different one. Sorry for that mix-up. The y1 value is 21 because it goes x then y, so 21. Yep, there we go. We rearrange, and we're going to solve. So it becomes plus 21 over here. 1.2x, 1.2 times 30. Oh, what's up in there? So it's going to give us 1.2x minus 1.2 times 30, that's 36. Yep, 36. Okay. Then simplifying this down again, negative 36 plus 21 is going to be minus 15. So now what I'm going to do is talk about a couple of things with this answer, because that's all the worked example wanted us to do. But I'm going to take it a step further and actually explain what it means in the context of this question. So with the equation of y equals negative 1.2x minus 15, our y-intercept is negative 15, and our gradient is 1.2. But what does that actually mean? Well, taking it at face value, it means that if you get a score of 0 in mathematics, you should be getting a score of negative 15 in physics. Let's think about that logically for a minute. Okay. Is it actually possible to get a score in negative 15 on an exam? No. 0 is the absolute worst you can get. So already we're seeing what we call kind of limits or boundaries with our model. Okay. And that would be, okay, looking at this, it might only be accurate for potentially up to getting, what's that, 12 or 13 on a maths exam. Okay. Now, the next thing to look at is the 1.2. What does that actually mean? It means a rise over run. What that means is if you get, for every 1.2 marks you score in, just make sure I've done this correctly. Yep, so the y value is physics. For every 1.2 marks you score in physics, you're scoring 1 mark in maths by the looks of things, okay? And that's how to interpret it. Now, what you can do with this is what's known as interpolate your data or extrapolate your data. If I go back up to my graph here very quickly, I might go back to the textbook for this one. As you can see, the points that we've been given stretch from here to effectively here. If you wanted to use this equation that we've made here to find a value, okay, what if I scored 95 on the maths exam, what should I get? That's an example of extrapolating your data. Because if we have a look, particularly at the maths scores, no one scored higher than 89, did they? So what we're doing is, just like extrapolate suggests, EX, we're exiting our data. We're extrapolating our data to make an estimate based on this line of best fit or regression line. Okay? Interpolate, you're inside. IN, inside. Interpolating means you're inside the data. If you have a look in here, no one scored a score of 55 in mathematics. So you could use this line to estimate, if someone scored 55, what someone should be getting in physics. That's interpolating your data. Okay? Those are just some terms you're going to have to get used to in the future, particularly during Units 3. Anyway, thank you very much for watching the video, guys. That's all for that one.